Hello, everybody. Welcome to the webinar. My name is Koen Maddens, and I am the Global Automotive Solutions Architect for Amphenol Commercial Products Group. I will be the speaker today. Today, we will speak about the signal connectors, modular solutions, lightweight solutions, data connectors, power connectors, all used within the ADAS. And at the end, there will be a Q&A. If you would have any questions during this session, feel free to fill them into the question box of this meeting, and they will be answered at the end of this session. The connectors we will discuss for today are used in the powertrain unit and ECUs, central computing units, linked to applications like the camera, radar, LiDAR, and used in zonal architecture. I would like to start with looking at the automotive architecture for data connectors, where we see that there is a data connection inside the control units, which is using PCI Express. This PCI Express channel from the chipset is translated to Ethernet or to a coax. But why is that? The reason for this is that why do we have this different type of protocols is because the PCI Express has a very high-speed chip-to-chip communication. It is optimized for the port. It has an ultra-low latency. The disadvantage is that it goes over a very small length. When we go to Ethernet, and Ethernet has an IP protocol which can be programmed easily. It can travel over much longer lengths, but it has a higher latency. With coax, we have again a low latency. It can travel also over long lengths, but it's more difficult to program. Now, why I'm saying this is because if you look to software-defined vehicles, the software will become more and more important into the car. It will also be a cost driver for the car. So making the software more easy and simple will be an objective for the future where Ethernet might start to play a more important role. This slide I have implemented to show where we as Amphenol are located. We are a market leader in the high-speed backplane connectors. We have all competences in-house to drive this market and to build the connectors for the future. Having this competence is an advantage for us also in automotive Ethernet, because we can use the same experience we have gained outside of automotive in our automotive developments or data connectors. When we look to automotive itself, we are at L3, which goes to a speed of 1 to 2.5 gigabits, L4 2.5 to 10 gigabits, and even if we go to an L5, which will be higher than 10 gigabit, maybe even going to 25 gigabit, it's still much lower than what we see outside of automotive. So I'm confident that Amphenol has the competence to build those connectors for the future. What is our history in automotive Ethernet? So Amphenol started off in 2018 with building the first net bridge, a 100 megabit to 1 gigabit. At that time, all suppliers who built those connectors had a different type of interfaces. This was a rather big connector. At the same time, we already understood that the connector has to be downsized to fit in future applications, and we built NetBridge Plus. NetBridge Plus was a fully shielded connector which is using cassette systems for the bottom row and the top row. The housing is actually a housing for the board connector, can be used in sealed and unsealed application. So it's easy. It's a very modular system what was easy to switch between the different type of modules. Unfortunately, we were not a market leader in automotive, and our customers has chosen another interface for the future of the Ethernet connectors. And in order to meet that requirement, we developed VNet. VNet stands for Vehicle Network. It holds the same technology as NetBridge Plus, but it can meet the customer's needs for today's automotive internet. Also, this connector will be qualified US car and LVP40. What are these needs for the customer? And so the customers want to have now connector systems which are matable with other suppliers. So we need to make sure that our interfaces can be made with a board connector from another supplier or the other way around. This for sealed and unsealed applications. And in the middle, you see a contact carrier, which is built into a cable connector. Also here, we have to make sure that our contact carrier can be built in a cable connector from another supplier. We call that contact carrier cavity compatibility. So we are fulfilling this according to the US car requirements because all this information is published there. But in case customers are not following US car, we can discuss their specification, and we will also meet that one. What did we develop for VNet? VNet we developed for the unsealed board connectors right-angled, vertical, and I want to draw your attention also to the right-angled ones with a reversed interface, which looks at the first instance a bit strange. But the reason for this is actually to have a lower height of the total application. Every application, every control unit has a PCB, and underneath the PCB, there is always some space in between the bottom of the PCB towards the bottom of the cover. This space we are using for the latch, and like this we can reduce the total height of the control unit. We have also an inline solutions. We have a 90 degrees. I also want to draw your attention to our 90 degrees cable connector, which is a mini version. It's a very robust system. It includes all automotive features, and it is proven technology for Amphenol that it is really working in automotive environments. You have also the hybrid solutions where we combine the signal with the Ethernet. And then as last one, we have the VNet E, the economical version where we are going for the lower speeds, the 100 megabit, where we removed the shielding from our contact carriers. And by doing that, we have cheaper and a solution for the lower speeds. You can have two types of cables here. You can have a cable with a jacket, which you see on the left side. Then you can have also unjacketed cable, which is just a simple twisted pack. So although these contact carriers are not carrying any shielding, they are all interchangeable. So we can interchange the contact carriers between any type of housing. Also, we have a sealed versions developed. We have right-angled sealed versions. We have inline sealed versions, hybrid sealed versions, and also for the unjacketed, we have the sealed version available. So this was everything for our VNets. When we look to HSD, HSD is another connector which can carry LVDS for camera, USB, Ethernet signals. This is a legacy product. It's already there for many years on the market. It's already used in many different applications. Amphenol has also developed all those type of connectors going from vertical to right angled, combined with signal kind of hybrid connectors, sealed special versions, 90 degrees cable connectors. It's all available at Amphenol. Floating board to board. So to connect two PCB boards, then there can be a misalignment, and if the connector is not the guidance between the two PCB boards, we have to be careful to have no stress on the solder tails. For this, we have a floating board to board. In this floating board to board, you will notice that the stress is accepted at the red areas, and the red areas are the ones which are not linked to the PCB. Like this, during vibration, we will not have any issue with the breaking of the solder, and we can accept a misalignment of the two PCBs up to 1 millimeter in X, Y, and Z direction. This connector has a minimum durability of 20 mating cycles. We have a sufficient long wiping length, as you can see here on this picture. They can be combined with power contact and signal contacts, or only single contacts, and we can do also only power contacts. This connector can run signals for PCI Express Gen 4 or for Ethernet, and it is compliant with all US car requirements. We have two different heights. We have a height till 15 millimeter and till 30 millimeter. They both have a different construction, but both are meeting also all the automotive requirements. Now, we have spoken in the beginning about Ethernet and about speed. We also have seen that and discussed with other customers that the speed has to increase. So also Amphenol has been working on a solution to meet the PCI Express Gen 5. So if you would have interest in this type of connector, we can have a private discussion about this new development. If you would have other protocols as PCI Express or Ethernet you want to run over a floating board-to-board, please let us know, and we will work with our SI engineers to define the right pinning assignment for that connector. If you don't have a float, you can use DensiStack. DensiStack is a misalignment connector. That means that the center of the PCB at the top and the bottom has to be exactly in the same position. If that is not the case, you will put stress on your shoulder pails, and again, as already mentioned, during vibrations, your shoulder might break. We have here a misalignment of plus minus 1.6 millimeter. That means you have chamfers on the connector, which will guide the connector to each other's center. We have three versions. We have a version without shielding, with split shielding, and with a full shielding. This connector is a US car qualified connector and can also run PCI Express Gen 4. The current on the signal contact is 1 amp, and the power we are actually running over the shielding. This connector can go up to 1000 position and is SMT soldered to the PCB. It has a stacking height from 1 till 30 millimeters. Zonal architecture. I don't think we have to explain zonal architecture. Most of the people on this webinar will know what the advantages are of zonal architecture. But the question is, what can we do as connector maker to meet those requirements, to have less cabling, to have a lower cost, less weight into the car architecture? For this, we developed the ComboNet. If we pay attention to the right top picture, you will see, for example, 4 different types of mini FACRA. In the ComboNet, we can combine that into one connector, in one module. So we will combine all those into one, all these discrete connectors into one interface, which will save already space around 30% on the PCB. Also, another advantage is at the OEM, they will not have to mate as much connectors. So in this case, you will need to mate around 8 connectors. With ComboNet, you only have to mate 1 connector to connect the same amount of signals. And another advantage is that for every discrete connector, you need a coding. So we have 4 mini FACRAs. That means I need 4 codings. If we want to do that fast at the OEM, we need to give them a different color to make sure that the operator sees them. So it's all increasing cost and making it more complex. With ComboNet, you combine all those into one module, which has actually the coding of the total connector. So then imagine that we would go for a sealed version. A sealed version, every connector has a shoulder and the shoulder has a certain type of angle. Depending from customer to customer, that can go from 10 to 30 to 45 degrees, which increase the spacing between the different type of discrete connectors. If you then have to seal off this unit to your module, that will also increase the size a lot and make your module very complex to seal off. With a combo net connector, of course, you have only one interface which you have to seal off to your unit. What type of versions do we have? We call that a standard combo net, and you can have a customized combo net. Why do we call them like this? With a standard combo net, we will use modules. Each module has the same size, and we can interchange them. You can put the module from the VMAT instead of the mini FACRA in the two position. It is as you want, according to your own pinning assignment. This connector also has a large lever system with an implemented slider to reduce the force with approximately a factor of 14. If you go to a customized version, you will see that you have, of course, many more pins into one module, but we cannot combine that anymore. This will be very customer specific. In a sealed application, the smaller modules are actually an advantage. The reason for this is when you put a seal around a separate module, the tension of the seal in the middle will be much larger than when you have a very big interface. The seal in the middle will be more loose, and what can happen is that it would roll back during mating, with as an effect that you would damage or you would not be able to mate the connector at all. When we look what type of terminals we are using in our modules and what type of modules we have, it's endless. You can do whatever you want. We can put data connectors, power connectors, signal connectors inside, signal terminals inside our modules. If you have a certain preference for a terminal system, you can let us know, and we build a module according to that terminal system. The only thing which is limiting, but it can still be adapted, is the cable size. If the cable size is too big, the minimum bending radius might cause that our connector is getting too large, and then we will have to review together with you how we address that issue. We will have standard modules. Standard modules contain every time the same type of contact system. The hybrid modules are combining different type of contacts. Why do we do that? If you have a pinning assignment and the pinning assignment we would only have standard modules, it might be that one standard module would be filled for 50%, 30%. If we have many modules like that into the application, it might be wise to go for a hybrid solution which combines then the filled holes and you lose the empty ones and you have a better density of your total application. Lightweight solutions. So we have already worked now on zonal architecture. We try to reduce the amount of cable. We try to work also on the weight. Why not working on the round cable to reduce the weight of the connector based on flex connectors? So I would like to introduce to you as well our flex connectors. We have as first flex lock. Flex lock is a 2.54 and 3.2 millimeter connector, which is initially designed for BMS systems. But nowadays can also be used in other applications or other fields. So we have a flex to board and we have a wire to flex. The flex to board you can have in a vertical and a right angled version, and the wire to flex you can have, of course, in straight versions. Here, this is a more traditional way of connection. What does that mean? That means that you have a terminal and a male pin. So you have a terminal system, a metal terminal system on the side of the flex, and on the other side, what you solder to the PCB, you have male pin. This female terminal is then soldered to a flex. The connector fulfills also all automotive requirements, and because of the larger pitch, we also fulfill the 48-volt requirement with this connector, which is today a new requirement within the automotive. The current rating is at 2 amps, and if you if you have a 55 degrees Celsius temperature rise, you can go up to 7.32 amps. Another type of connection system of the flex is where we would transfer the spring. If we look to the left bottom picture, you will see a board connector, and this board connector is containing the spring. On the side where you see the flex, we do not have any metallic contact anymore. So what happens is we insert the flex into the connector. We have this blue part, which we call an FPA. FPA stands for Flex Position Assurance. So we will make sure that the golden fingers on the flex is in the right position to have the right wiping length after mating. Now, the FPA has also a secondary function. It also makes sure that there cannot be any misuse in the production. Same as with cable connectors, operators at the OEM might be pulling on the flex with high force and treating the connector not as it should be treated. And we need to make sure that the flex remains into position, that the electrical connection is not jeopardized. For this, the flex retention force is set at 110 Newton according to US car. The US car is actually an LV214, a wire-to-board specification, but Amphenol use also this specification to develop their new flex connectors to make sure that the lessons learned on the wire-to-board and implemented into US car are also applied on our flex connectors. Of course, not having a contact on the flex side makes the connector again lighter, easier to terminate, faster to terminate, and having a low mating force. You can have these connectors in the 0.9, 1 millimeter, 1.5, 1.8, and 2 millimeter pitch. It has also perfect working CPA system, can use for FFC and FPC, and it is touch proof. So you cannot touch with your fingers on the interface of the flex side the golden fingers. We have these versions available in flex to board, flex to wire, flex to flex, and in a dual and a single, which means the dual means that we have two flexes coming together in one receptacle housing, which can then connect to the board connector. FlexFast Mini, as always in automotive, connectors are too big, so we have to make them smaller. That's why we developed the FlexFast Mini. It's a 12-position connector, but it has the same kind of functionalities as we have on this bigger brother. So it also has an FPA, which has a 110 Newton retention force, flex retention force, a current rating of 1 amp, and it has a dual beam. So that means you have two contacts per golden finger to make sure the connection is guaranteed between both sides. We have looked now at the newer flex connectors, but we also have legacy flex connectors called ZIF and Autolock. ZIF stands for zero insertion force, and Autolock stands for you push in the flex and it locks automatically. Zero insertion force means you can see on the middle picture on the top one mentioned there. I don't know if you can see my arrow, but that's an actuator, the black part. The black part will be vertical. We will place inside the flex on top of the contact, and then this is with zero force, and then we push down the actuator, which will push the flex onto the contacts and create the needed normal force to have a good electrical connection. Autolock is different. Autolock, you don't have to push on an actuator, you just have to push the flex inside the opening. The actuator will go open and close from itself. In order to release, in both cases, you have to push on the actuator to take out the flex. These connectors are US car and one is LV214 qualified. Of course, even with the previous one, we could meet the US car closer. With these ones, they are, of course, more traditional connectors, but we imagine to use these connectors in an automotive application, and we need to guarantee a good connection. A good connection during vibration, environmental conditions, and this is exactly what we are going to test and why we classify those connectors as US car. I display here 5 of our connectors. We have much more. So, but upon request, and if you have a project where you can use such a connector, please let us know and we will make the proposal and show the qualification. In case you need additional ones, we will also work with you together to get you the needed proof that this can work in your application. Now we had the FlexFast and we had the ZIF, and now we have the FlexFast ZIF. What does that mean? What advantage does this connector have? Now, if we take the FPC, but it can be also an FFC, you push it inside the cable housing, you push on the FPA, that means again that my flex is in the right position. I will make the mating. During the mating, the flex will be lifted up and there will be no electrical connection. So there is a very low mating force between the both sides. Then once you have done the mating and the latching, the primary latch is active, you can activate the CPA. The CPA looks very big on this connector, but the CPA has a double function. The CPA has a function, of course, to ensure that we did the full mating, and prior to full mating, we cannot activate the CPA. So when we can activate the CPA, the mating has been accomplished, but then we will also have features inside which will push the flex down onto the contacts and the electrical connection is made. So as long as there is not made a good mating between the two sides, you will have no electrical connection. Other than that, FlexFast ZIF has exactly the same properties as the other connectors. So it has a 1.5, a 1.8 and 2 millimeter pitch, US car graded. If there are other ones, other specifications which we have to respect, please let us know. FFC, FPC can be guaranteed to amps, dual beam, everything is implemented and disconnected. Now we have spoken about the flex and we have spoken about data connectors, about combo connectors. We did not speak about the signal and power connector, what we are going to do as Amphenol. First one is a connector which is already widely used into automotive. Many customers see it already as a standard. We started with our first generation. It's called Microspace. Microspace is not just chosen as a name. It was developed for the lighting industry to have the smallest connector on the market, establishing the properties for reaching 4 amps at 80 degrees Celsius. Now, later on, we said we will continue this family because that was very successful, but we will increase it and we will call it Microspace XS, which stands for Extended Standard. And we prepared an unsealed solution for wire to board, a sealed solution for wire to board, and for wire to wire also sealed and unsealed, both meeting LV214 and US car. These connectors are available with a top and a side latch. They are available in stagger configuration. What does that mean? Staggered means that the bottom row and the top row is shifted towards each other. So in the interface, you have a 2.54 millimeter pitch between the two contacts. But as they are shifted, when they come out on the backside, they are bending those contacts in between each other. And on the PCB, you have only 1.27 millimeter pitch, which saves space on the PCB. The soldering on the PCB side is done by SMT, and you can have a right angled and a vertical version. The wire to meet the 4 amps is an AWG 22, which means 0.35 square millimeter. And although this connector was designed before the 48 volt requirements, we also investigated what kind of voltage we can reach with our connector. Because of what I just explained, that we bent the contacts in between each other on the right angled version and at 1.27 millimeter pitch on the PCB, we cannot meet the 48 volt for the right angled version. But for the wire to board vertical, and the sealed wire to board right angled and vertical, we can meet those requirements. The IP rating for our sealed connector is IP6K 9K, so we went for the highest type of sealing class. And we have also an ECPA version available, which can be discussed upon request. So if you have any question, we can send our sales to show you that type of connector. Wire lock, we spoke about flex lock. We have also wire lock. This was also developed initially for the PMS systems. Meanwhile, also used in many other type of fields. I forgot to say that, but also microspace is not only used anymore in the lighting, it's also used in all different type of applications. We will have wire lock with the wire to port, wire to flex, wire to wire. So you see it has also all the same combinations as we had at flex lock, but with a 1.8 millimeter pitch. Of course, we cannot reach the 48 volts in that case. This terminal systems go up to 2 amp. And then we went for the next generation where we need the 48 volt. We are introducing our new connection system called ACAT. ACAT will be a 0.64 millimeter pin. We consider that as a robust interface. That's why we have chosen for this. You will have this available on the board side with a solder SMT or with a press fit version. The connector, of course, will need a 48 volts, has a pitch of 2.54, and the cable size is now 0.75 square millimeter AWG 18, which will go for 8 amp at 80 degrees Celsius. Also, at this type of application for high vibrations, we will have silver plating available, and also tin and gold plating will be available. Power. Amphenol did not have power connectors for automotive available, so we started to develop our power connectors for low voltage. We will have the range from 6.3, 9.5, and 12 millimeter versions with horizontal and vertical blades, waterproof and non-waterproof. But where we also want to differentiate from what we have currently on the market is on the 48 volts and on the size. So we try to reduce the size to have a mini version of to bring the power onto the PCB. Now, I can understand that you believe 48 volt, not so difficult with power connectors, which is right. You have a thick cable, so you have a higher pitch, so you get the pitch and clearance distance. It's easy to meet with the power connectors, except for the horizontal blades. And horizontal blades on the PCB side, the solder tails will be very close towards each other. So we have seen already on products which are on the market that the 48 volt is difficult to reach with those type of connectors. We will have 2 positions and 4 positions available for this type of connector. Repairability, this is also a new trend because all the ECUs become more and more expensive, all the PCBs in the ECUs, and there are more and more PCBs in one ECU. Where in the past the two PCBs were soldered together, we see now that customers want to have an interface which you can separate. One of the solutions to separate, of course, you have the floating board to board or like connectors like Dancy Stack, what we saw in the beginning, but you can also use a cheap pin header, which is also not designed for automotive, but used inside automotive a lot. We have two types of pin headers. We have a burr stick and a burr strip. Burr stick means you have a connector which you will put into a tape on reel and deliver with a defined pin count to a customer who will put this on their PCB. In order to have the interface separatable, you will have a D-box connector on the other side, which contains a spring contact, which can be entered either from the top of the connector or can also, when you drill holes in the PCB, can be entered from the bottom into the D-box and establish the electrical contact. We have this type of pin headers with double row, single row, right angled, vertical. I propose if you see usage for this type of connector in your application to inform us, and we can then look what kind of connector is the most suitable for you. We have also the Berg strip. This is endless, so we call that an endless process, where we have a molding process where we actually make around 30,000 housings on one reel, where we stitch in the contacts afterwards into that housing. You have an interface, a contact interface of 0.63 contacts for pin and paste. We have also a version for SMT, but also the orange ones are not tooled yet, but these are also possible in an endless process. What is the advantage of an endless process? Of course, at the customer side, you can cut the connectors at the pin count you want and you need for your application. And we do not have to waste money on a tape on reel. And we do not have to waste money on the cutting process. So that means that at the end, the total cost of that connector in an endless process is cheaper than when we sell that in a table reel. As the last point, I would like to show again other products, and actually all products which are on our website, which are not classified automotive. We see more and more customers using those connectors inside automotive. But how can this be used? So I can imagine that you are wondering how we can make sure that these connectors are okay for your application. So you will see that some of those connectors are mentioning US car, and all of them are using a different type of US car. This is because customers go on the website, they see a connector which can be used in their application, and they contact Amphenol. They are asking us, okay, we have this application with this type of requirement, would that fit for this connector? We can, although the connector, for example, if we pay attention to the mezzo stack connector has no US car qualification, but it does not mean that it will not meet a US car qualification. It means that we never tested the US car qualification. So we will have to review them internally, and also this can be strongly application dependent. So I advise that you ask us also to have a look in your application to support you to make sure that there are no quality issues arising after this connector has been implemented. If you look that they are all having different type of vibration class and temperature class qualification, that does not mean that this connector, that this is the maximum vibration class and temperature class for that connector. That just means that that customer needed this qualification for his application. So if yours would be more strict, let us know, and we will review if we can use that connector for your application with your more strict requirements. And with this, I'm at the end of my presentation. Um, I hope you enjoyed it and that you could have a better vision and look on our products and what the new products are going to be. If you have any questions, please let us know and we will answer in the next session. Thank you very much. I see here a question. Do you have a protection cap for the board to wire connector? I guess that this is for microspace, maybe. Um, so I do not think that we have a standard cap on it, but I'm sure that we can foresee such a cap on those connectors. Another question is, how are you sure that the cable retention force of the VNet E version is meeting the automotive requirements? This is also a good question. The VNet E, of course, has an unjacketed cable, which means the cable crimping is uh, much less strong. But in this case, the cable has also a thicker cross section. If you look to an STP cable, you will have a cross section of 0.14 square millimeter. And for a VNet E, you will have a cross section of 0.35. And then we actually fulfilling the automotive requirements according to the standards which are mentioned in there. Another question is, could you confirm whether the ComboNet connector high current pin integration with a single line, the power circuit is expected to carry current exceeding 40 amps? So that would be a 6.3 terminal. I I believe that with the 6.3 terminal, our module is already quite filled. So I think we can implement two of those. We would have to check the spacing then in order to add also some signal contacts. I would advise, if you would like to have that we see the total pinning assignment of your application, and then we can make such a proposal. Um, Another question which came up is when I correct understood, the 90 degrees version of the cable connector of VNet has a different type of contact carrier. Does this also have a cavity compatibility? So at this moment, for VNet, the 90 degrees version at the cable side is not a connector which has to have the cavity compatibility on the for the contact carrier. So for the interface, you still have the interface compatibility, but for the contact carrier, you do not need to have the contact carrier cavity compatibility. Another question is, will the board-to-board connector be tested by Amphenol or will this need to be outsourced? For all board-to-board connectors, we are fulfilling the requirements according to US car and to LD214 or to specific requests of the customer. So if you, for example, have, I'm not sure where you are, which type of test you are referring to. But if it's about signal integrity, of course, we will also run our signal integrity tests on it. If it's related to the current, we also do the same thing. So I invite you also to review our test reports, which we already constructed, but we are doing for our board-to-board connectors also the testing at our site, initial testing, and then in production and in really qualifications, there are also tests done. Another question I see, can Dancy stack also be soldered to a flex, for example? Yes, it's actually possible. So you can connect with the flex, two sides of the Dancy, at each side of the flex Dancy stack, which you then connect to the boards to make a jumper between the two boards. You have to pay attention though that you make sure that they are fixed very well to the board connector. And another question, how friendly are those product lines to the current wiring harness production automation solutions? I guess this is referring to ComboNet. Um, so of course, all other connectors, all cable connectors related to outside of ComboNet, they are all ready to do full automatic crimping process and insertion. If we look to ComboNet, all modules are following the specification to have the ability to have a full automated crimping process and insertion process into the modules. Another question which came up is, will you work on floating board-to-board solutions which will even meet PCI Express Gen 6? Yes, we of course want to increase the performance of every connector. We see that there are certain customers already looking into that. So we are supporting those in order to meet that kind of requirement as well. So if you would have those requirements, please contact us and we can have a discussion, and we will involve also our SI guys to have this discussion with you. Another question which came up, VNet cable assembly, is that shielded? I will quickly try to go back in the presentation. For VNet, of course, we have STP cable. So everything, if we look to this contact carrier, for example, we have complete shielding outside of the contact carrier, and this is connected to the braid in the STP cable. So all those connectors, except VNet E, are going to 25 gigabits, and they are using all STP cable or shield cable. Please let us know if you have other additional questions. I think if there are no other questions, you can always contact our local sales or put your information to the webinar, and we will then go in contact with you.
Thank you, Cohen, for giving us this presentation today. Everyone who's registered will receive the link for the recording, and it will also be posted on YouTube and our website. Thank you, everyone, for joining us.
Thank you. Bye-bye.